A while back I did a video on the mystery of this Joule Thief over here. I had it sitting around for several months. I didn't use it, and during that time I found this thing on 3 different times, and that was a mystery to me. One of our viewers suggested that the LED might be producing enough electricity when exposed to light to charge the system, and I thought that was an interesting idea, so worth testing. I'd never heard of it before, so perhaps it's a myth, perhaps it's reality, but easy enough to check, right? So today I've set up our system. It's just quite simple. It's an LED meter, and then over here I've set my lights up a little differently so that I can hold up the LED to the lights and test it. Okay, well, let's get started. With the LED covered, we don't get much in the way of voltage. I got it under my hand over here, and when I take my hand away and aim it towards the light over here, it starts going up. I'm blocking the numbers, and as I block the light off, so it's definitely not just like picking up electrostatic interference from the light. It's actually doing something with the light, so that is interesting. Now this is DC. I've got the meter set to DC. So let's see what we can max this out at. 0.1 is the most I'm seeing. 0.12. Oh, there's 0.22. What did I do? So let's call it about, okay, there's 0.2. So if my hand were steadier, I could probably hold that 0.2. So let's call it 0.2 volts. Let's change our setup a bit. We'll switch over to microamps and take a measurement to see what kind of current we're getting. And to take our reading, wow, yeah. Looks like the best we're going to do is about 0.01 microamps. Now, I realize I should be taking voltage and the amperage readings together, but yeah. We're going to get at least an approximation of how much power this can produce, and after all, the idea here is to see if we can generate enough power to have charged a capacitor to run that Joule Thief. Okay, so it looks like 0.01. I'll go off and do the calculation and see how much power that represents. Well, from our experiment, we found some interesting information that an LED will in fact produce measurable volts and amps when light is shown on it. So that's a very interesting finding. Now let's take it one step farther and ask the question, can an LED charge the capacitor for a Joule Thief enough to make it come on? Okay, well, let's run through the calculations quickly. From the blue LED, and that's the one that was mostly in the video, we had 0.2 volts, 0.1 amps. That gave us roughly 2 times 10 to the minus 9 watts. The red, which was the best, and by the way, it is the one that is on the Joule Thief, is 1.32 volts. That's a significant amount of voltage. And 1.45 microamps, small, but it still gives us almost 2 times 10 to the minus 6 watts, which is, 3 decimal places better than this one. Okay, the yellow LED was number 3 in power output, so it gave us 1.4 volts and 0.6 microamps, or 8 times 10 to the minus 7th watts. And the green gave us 1.5 volts, 0.8 microamps, and 1.2 times 10 to the minus 6 watts. Okay, so let's look and see how long would it take to charge the capacitor given that amount of watts input. Now this is the formula I use down here, where C is the capacitance, V is the charge voltage on the capacitor, V is the depleted voltage. I assume 0. Now, the capacitor could have been, very nearly charged, and a little extra voltage could push it over the top. But I assume 0. And then amps, of course, are amps up here. So we just plugged in this data up here into this formula down here. So with a blue light, how long would it take to charge the capacitor? And the answer is 19,800,000,000 seconds, or 229,000 days, or 627 years. Plus the fact that the blue is not pushing out enough voltage. It's only got 0.2 volts, and the Joule Thief comes on at 0.33 volts, something I measured at a different time. Okay, the red charge time would be 136,000 seconds, or 1,580 days, or 4.33 years. Now this is the best one, and again it's the one on the Joule Thief. If the capacitor in the Joule Thief was almost fully charged, this could possibly push it over in a matter of just a few weeks, and yeah, that's a possibility. The yellow one was the third best. It was 1.4 volts, 0.6. It gave us a charge time of 330,000 seconds, or 3,800 days, or 10.46 years. Yeah, not as likely. And the green, the 1.5 volts, 0.8 microamps, charge time of 247,000 seconds, 2,800 days, or almost 8 years. So this is the number 2 place. Okay. So yeah, it is possible that if the capacitor were mostly charged, that this could push it over the top. However, we also have to keep in mind that the lights used in the video were abnormally, ridiculously bright. They are my video lights, and I held the LED right up against them. And there was a maximum of 3 weeks for the capacitor to charge. But, if the capacitor were just right there at the edge, yeah, within 3 weeks, it might be able to push it up to a point where the light came on. Okay, well that was it. Some interesting findings. Yes, LEDs do produce voltage and current when light is shown on them, and it is unlikely, but it is possible that the LED could be the reason that this mystery Joule Thief came on by itself. Okay, well that was it for today. I hope you found it useful and interesting in your home electronics projects.